Hello everybody. In this video we're going to talk about the relational and logical operations. So before we start and do the work in Matlab, I want to just quickly talk about what we mean by logical operators or operations and the relational operations. So the logical operations or operators are are symbols or words that we use to compare values of two or more expressions or variables or whatever, and this comparison will give an output of true or false. So I'm saying, like, what we say here is a equal to b or not, a smaller than b, bigger than or smaller than or equal, bigger than or equal. So these are just comparisons between a and b, and depending on the comparison that I'm doing, it will give an output of true, meaning that this condition that I am putting is true, or false if it's not true. And you'll find that all of these symbols or the syntax that we use is very simple, and it's very logical. It's like what we would use even in Excel. But we have just the only difference here, or whatever is the only kind of new thing, is that a equals to b is not only one equal, it's two equal. And this is because if you put a equals b, then you are changing the value of a into the value of b. You're not comparing the values, you're changing the value of a. And that's why this is the only thing that we need to know. When you do this comparison, you will see that the output would be either true or false, but the MATLAB's output is not going to be true or false. It will be 0 or 1. 0 represents false and 1 represents true. So let's put any values. Let's say a equals 10 and b equals 15, c equals 15, for instance. So I have only three variables here. Each one of them is scalar, no vectors. And now I want to check if a is greater than b. And you would notice kind of two or three things here. The first thing is that it is giving you the output as logical. It's writing logical. And if you recall that when we do the function handles, let's say I see g equals at x of x plus 1, it writes something like this. It tells you it is a function handle, and it tells you here that it is logical. And this is because the output now is not just a number. This 0 is not a number, or MATLAB does not see this as a simple number. When you check this, the output here, which is the answer, is 0, and it tells you that it is logical. And I'm sorry, and the icon here is a square with a tick mark, and it tells you that it is, again here, it is 1 by 1 logical. So it's a logical statement. You can treat it as a number, but MATLAB sees this as a logical expression. We can try the opposite. If a is smaller than b, and this is logical, and the output is 1. Of course, you can put the output as give it a name. So I can say, or check if h equals, and this is one thing that is kind of confusing sometimes. If you want to check if h equals c, if c equals 1, you kind of might be confused because they have equal before and equal after, but this is not a logical expression. This is a logical expression because we have two equals here. So it tells you that c is not equal to 1. You can do the same for b, and it tells you b equals c. If you do it with a, it's not gonna work. We can check if a is smaller than or equal b, then yes, because a is smaller than b. So you can try all kind of combinations of numbers that you have. So this is the first thing. The second thing is that you can, I'll clear everything now. The second thing is that you can do this for vectors or for matrices. Let's say a equals 1 2 3 4 5 6 7 8 9, and then b equals, let's say, I just push it here, 10 20 30 4, 5, 6, 7, 80, 95. Just I'm putting any numbers here. And you have now A and B, and these are the values of A and values of B, and you can do the same thing. I would say that V equals A equals B. So I'm checking if A equals B or not. And in this case, it will compare each one of them with the corresponding values, like addition, subtraction, and the elemental multiplication and division. And in this case, it's gonna be a matrix, but it is a logical matrix. And this is what we see here. It is 3 by 3 logical. And it tells you that the first row doesn't have any values that are equal. The second row is totally equal, which is what I have here, 4, 5, 6, and 4, 5, 6. This is equal, but the others are not. You can do the anything if it's smaller than or equal B. If it is greater than B or equal B, it's gonna be the same thing. And I can check if it is not equal to B. If I remember that right, it's gonna be no, it's not that. This is the symbol that we use in Excel. I got confused because we in Excel we use this if you want to put not equal to. But here you put something different, which is equal, but you put this not, which is the shift and the button or the key to the left side of number 1 on the keyboard. And in this case, it is gonna give the opposite of this. So if A equals to B is giving zeros and 3 ones, 1 and 2 zeros, it's gonna give the opposite. Or it's like giving minus or the not V. So it's gonna give that. You can do this also for, let's say x would be A is smaller than or equal to, I'll put any number 15, so it will compare all the values of A with 15. We have A is all smaller than 15. B would give different values here. Yeah, you will find some greater and some smaller than B. Keep in mind that it is kind of elemental or element-wise process. So if you put P, for instance, equals 1, 2, 3, 4, 5, 6, and you do the comparison instead of A and B to be comparison between A and B, it's not gonna work because there are three values in A which are or do not have any corresponding values in B, and that's why it's not gonna do any calculations now. It does not, it's not able to do that. So this is what we see here, and this is how the icons will look like. So you know that they are logical outputs. The second thing that we need to discuss is the relational operators. By the relational operators, we mean that they are symbols that we use to connect more than one logical sentence, and it's kind of well-known thing. It's like and, or there are three actually. It's and, or, and not. The and is the shift and 7, or is the shift and the button or the keyboard, the key that's below the backspace, and the not symbol is the one that we just mentioned before. And if you have true and true, the not x is the opposite and said not before. The or will give 1 true, and the and will give true. So this is the only condition that and will give true is when both are true. The only condition that or will give false when both are false. If any of them is true, then the or will be true and the and will be false. So it's kind of well-known thing. We can kind of I'll clear that. I'll put the value of A, B, and I'll make C equals. I'll put any numbers here. We can do rand. I think there is rand 3. So it's gonna make any 3. Oh, no, I want it to be randy. I think there was a function that's called randy. that, oops, and this Randy would ask you to give the maximum number. I'll make it 80, and to make it 3 by 3. Yeah, so I have now random numbers that are bit less than 80, and it's 3 by 3. So I have now this three matrices, and I need to do some comparison now. So I will say G equals, I want to check if A is greater than or smaller than B, and C is greater than 70, for instance. So you will see that it's giving this output. We can kind of check. We know that for the AND both have to be true. So for the first, the true will be this. So these first two are true, and this last one is true. And for A is smaller than B, all A is or these three are smaller than B, and these only these yeah, so some of them are smaller than B, but the only combination of both true is this. If you put OR instead, it will give you more outputs. You have now this this is smaller than 30, so this is true, but the other one is false because this is not greater than 70. This is greater than 70, but this is not greater than B. So that's why it gave the true here with the true here. So this is what we just mentioned now. The last thing we need to discuss now is what we call the find function. It's kind of useful sometimes to search for something. So for instance, in this example, we say that x equals negative 204, and we want to give or to get the output of y, which is find x. So find is giving the locations of the non-zero values. So for instance here, let's give it one more shot. I will give A equals 1 2 1 3 0 1 0 1 0 or 110 for instance, and I will type find A. When I do, it tells me that it is in location number 1 2, not 3 4, not 5 but 6. It works for logical, and this is what I mentioned before. Sometimes you would get logical operators that can be treated as numbers, so or logical outputs that can be treated as numbers. So I can here give B as not A. So it's gonna do the same. Not A, it's looking for zeros and non-zeros. If it is non-zero, it's gonna be considered as true. Zero is considered as false. So in this case, it will be the output will be 0 0 1 0 1 0, and this is logical. Okay, I can now have C as the find of B, and it's gonna give 3 and 5. Okay. So it's kind of pretty simple thing. And what you notice here that C now is a matrix. It's not a logical output. It is a matrix. Despite having the input of this as logical input, but it is treating it as numbers, as we mentioned before. We can do something like combining both. So I can put J as a greater than 2 and B let's say not equal 0. Okay, so it's giving, oh, let's put it OR because AND will give nothing. So this is the output of these two things. You can do find of J, or you can combine both. I can put this here and you get the output of these two directly in one operations. Let's say now I need to find the values of A that correspond to these these locations. So I can type this as A of all this, and it tells me that 3, 0, 0, and 10. It's 3, 0, 0, and 10. So this is what we do when we use the find function. Sometimes it's useful, or in many cases it's useful to use the find function to pick a place of something and then use it in another operations. So this is all for today, and I'll see you in the next video, inshallah. Goodbye.